Mark, how's it going?
Day.
I added a few comments to the documentation.
I saw that. Thank you. This is yeah, we need additional pairs of eyes for sure. Just let the people join. Um, I want to add yourself to the meeting minutes, and I'm going to start sharing. Share that. Oh, and I need to pull up this pull request as well because we really should take a look at it. Well, I'll tell you what. We don't need to spend time just sitting here. Manu, how are you? I don't know how you are while you're on mute. Hi, Ritika.
Hey guys,
Good day. How's
good day
life?
to you.
All right, so we're gonna pick up today where we left off yesterday. We have a few comments that we should review from Sudar, perhaps others. I wanted to ask a question. So we identified one of the attacks last time that the key store needs to authenticate the workload owner prior to performing all these operations. And now we hear, we say, at least in the comments, that the workload owner should authenticate or must authenticate the workload owner. The question is, does it deserve a separate step here? Basically saying authentication must be performed. Because there are other ways of doing it. Like, for instance, there could be a firewall rule saying we will only accept things from this connection. Like, you know, it's
It's
unclear.
it's another authentication method, right? So
Well, yeah.
it,
The point is, should we say it? Is it like is it cluttering the diagram to add a step?
so I'm inclined to think that we should put it there because, of course, I mean, what I liked last week when you made that comment about, or maybe I don't know if it was you, but anyway, we had these discussions about the verifier is in the TCB of the workload. So now
Yes.
what we are discovering is that everything that is upstream really of the workload ends up being the TCB of the workload. So
Yeah.
if there's no authentication there, now you have a huge unknown that is now in the TCB of the workload.
Yeah.
So
Okay. So we'll add. Um, let me then add a to do.
yeah,
Okay.
So
just
what do you
points in the
mean by
direction that everything is changed, right? And then we need to, every step of the way needs to be verified. Yes, sorry, I didn't mean to interrupt you.
when we say TCP on the workload, right? I would expect the verifier, key store, right, and C8 could be remote as well, right? I want to make sure when you say TCP, it still can be remote, right?
Yeah,
They're
yeah,
not.
yeah. What we mean is, it's not the right way of saying it, but it's in the trust boundary, I think is the better way of saying it, right? Is the everything that's part of the verification, which basically means that, where the reference values come from and everything, who put the reference values there. So the authentication of the organization, the entity that put reference value there, all of that is in the trust boundary of that workload. And the name of the game was to try to contain that workload and protect it from everything else. So now we see that to do that effectively, we need to contain the boundaries of everything else. And I think
Yes.
that's the aha moment that we had, where we realized you just have to go all the way and just chain everything and verify everything. And I think we are getting to that realization here.
Yeah. Okay, great. So we'll do that. I'm just going to go through the comments first, and then before we begin. So here, Sudar saying,
What I'm referring to here is right. So I know authentication, authorization of the workload owner is critical. Should we also have an expectation the workload identity and the simulated attestation results, right? Are those to be signed as well, or can they just be a claim, right?
so the workload identity is at a minimum, an SVID, so some kind of a URI. But it doesn't have to be if it's not whimsy. It could be any collection of claims. And the mechanism by which the workload owner decides what that identity ought to be, I think is outside the scope. We can call this out explicitly, basically saying, look, the workload owner decides how they decide, based on what they decide, not really our business here. Now, if there are additional security considerations here, we might want to call them out, like don't, willy-nilly produce any kind of identity.
I think the key question I have is should that be digitally signed, right? Like where the
But sign the
keystore
identity
has
itself, what
to.
do you mean? Like, what would you sign here? An identity is just a string. Or
There is no expectation that when the key store is consuming these identity, right? It is just a string or a set of claims, right? It's not.
it trusts the workload
Yeah,
owner
not.
to know what they're doing. Yeah.
So the key mechanism here is the authentication authorization of the workload owner,
Correct.
the actual claim. Okay.
Yes.
It's hard to have that confirmation, which makes sense to me, right? Otherwise, you are in catch 22,
Okay.
right?
All right. How about this? The mechanism by which actually, wait, let me.
But what I think your intuition, I'm sorry, how do you pronounce your name? I don't want to mangle it. Sudarshan?
Sudar, yeah, call me
Sudars?
Sudar.
Hey, okay, nice. Sorry about that. I just wanted to make sure that I say it right, Sudars. I think your intuition is correct that, yes, what we're saying is that it needs to be authenticated upstream. But what that means is that if there's another authentication actor, right, now the output of that authentication, right, that needs to be passed to the key store, whatever, needs to be signed by whatever actor has actually done the authentication. So it is, again, recursive, it's a workload that's doing the authentication of that user that's passing, information that another workload needs to rely on. So that needs to be signed. So it needs to have its keys. And so you end up in that pattern that we are surfacing here. So in theory, it doesn't need to be signed if we just say it's authenticated. But by saying it's authenticated, we are obfuscating the mechanism by which it's authenticated, which is most likely will be another workload, which means that it needs to pass some information that needs to be signed by the workload that did the authentication. So your intuition is correct, and that's the only way that we can detangle all this is to really start saying, okay, this is recursive.
Right.
Okay. All right. So this comment, should we resolve it now?
Yeah, I
Or
think so.
is there additional wording that needs to be put in before it's put to rest? I mean, there is a consideration. Let's see if it's in the threat model. Under the threat model, we'll find spoofing. Authorized entity placed request the key store resulting in identification. No, that's 3. There is tampering and EOP. We can add another one, basically spoofing, where specifically on step 1, if the wrong identity is computed, everything downstream from that is going to be broken. We can do that.
Yep.
So we'll do that. So we're going to say 1, it's spoofing. The workload owner is tricked into assigning the wrong identity to the future workload. Identity is a term we use here. Mitigation. Safeguard the identity computation mechanism and associated policies and I don't know. And proceed. I mean, we already said mechanism. Or maybe procedure. Right. And again, I encourage you to put additional wording or comments. I just want to make sure that this particular consideration is not lost to the future. All right. Let's see. But now we can resolve this comment, right, Sudhir?
Yeah, you can.
Sweet. Okay. To do, specify the workload or authenticate. Yeah, that's for future work. They're explained why the CSK pair must be stored, presumably for subsequent credential renewal without having to change the CSK. I'll do that. This is from last week, so we already agreed that we'll do that. Maybe I'll just.
So, Mark, do we need to store the private CSK in the
Yes,
store?
yes, we do because later it needs to be the private CSK needs to be returned, right, to
We
the
only
workload.
return the
Oh
CW,
no, if you
right?
want to, right. So if you ever want to do another, if you ever want to do another CSR, you'll need the private CSK. That's why. Right? This is for subsequent credential renewal. If you don't store the private CSK, then if you need to renew your credential, you need a CSR, you will not be able to do so. You will need to recreate the CSK. And this means that the credential is, I mean, if you don't want to do it, then don't, this is why I'm saying there is a to-do here. If you don't want to renew with the same private key, don't store it, don't need to.
I think for resilience, the system you're probably going to want to store it. And the way to store it is to wrap it, right? And then export it. And then you have that recursive pattern again that comes back. If you have a wrapping key, you can export whatever. But for resilience, I mean, we see it when some of our agents are, flaky, but sometimes when they come back up, they need to, go through another round. So
Yeah, makes sense. I didn't think about that use case. Yeah. Maybe it
there's
will be good to call it out somewhere, right? Like, yeah,
come
yeah.
again.
It may be good to call it out somewhere that, yeah, you still need to store the private CSK for this reason, right?
I mean, that's really implementation, but it's not strictly necessary, right? I think it's I think for resilience, maybe we have a section that talks about resilience of a system like this because everything is now cryptographically, protected. You can't go and mess with it, you can't go to the database and just tweak something, right? It's all very cryptographically locked in. So when you lose cryptographic material and you need to recover from a uninspected state, it is very tricky.
Sense.
Okay. So we did that. Let's go through the remaining comments. So, what is the trust mechanism between the workload owner and credential authority? Here I responded, you don't need any
Yeah,
because the credential authority has to issue credentials
yeah,
to
it's
us later.
just a CSR, yeah. But do we also need authentication in this step, probably? Because you're exchanging CSR.
Yes, we mentioned that last time. Let's see if it is reflected in the threat model. So in the threat model, this would be step 10. We did not say that. I thought we I thought we mentioned this, but I guess we didn't. Yes, we need, so under the threat model for 10, this is the CSR. This is denial of service and tampering. But really, what was the thing was that we needed to make sure that remind me if you remember, it had to do with the fact that if the CSR from the wrong key store ends up going to the credential authority. I do not know how much of a threat that is. But yes, I vaguely remember that this was the other significant threat that we've identified. Um, Again, so this is where when the credential authority returns the CSR, do we need some sort of a trust binding between the credential authority and the key store? I don't know about that, but I'm tempted to close this comment. It's just I want to know if there's anything you want to save from it. So if the question arises later, that the document has the answer to it. Sudhar, what do you think?
No, I think the primary mechanism is the authentication, right? Like as an owner calling the certificate authority with the CSR, how does the certificate authority knows that the CSR can be trusted, right?
Well, what if it isn't? Let's just like what's the actual threat that
Cannot have a public endpoint, right? That could just consume any CSR and
just credential,
happily
right,
signs.
right. Okay. Um, all right. So let me add a to do. Add an authentication step. So CA can authenticate either the workload owner or the key store that generated the CSR. Either is good, right?
Mm-hmm.
Okay. So that's now noted. Let's see, in the threat model, we might want to add something to the fact, right? So we're talking about denial of service and tampering on T. Um, so let's add T, and then can I unmerge the cells? Should be able to. Okay. So there is a spoofing threat here. The CSR from and unauthorized workload or owner or KS is sent to the CA. I'll expand these later. Resulting in CA issuing a credential to a to the wrong. Right. So basically, if I can contact the CA without authentication, and I know what workload identity I would like to assign to a workload, I can simply say, hey, issue me a CA around this, and pinky swear I have the private key. Right? So we're pretty much screwed in that point. CA must authenticate either or both of. Okay. That makes sense? Now we have a spoofing threat handled. Sweet. Okay. So now I can close your comment, right? There? Because we have the right. Well, I can't, I mean, I have a to do. I'm going to add a step in here. authentication step. Okay. Moving on. Let's take a look at this comment. In an enterprise implementation of key store that consumes the identity and the attestation results, it can be remote.
I think we talked about this already, so I think we're good. We are basically saying it is just a claim, right? Not a digitally signed.
Correct. So we can close this, right?
Yeah.
Okay. Next one. Key store can also validate digital signature of the payload itself for integrity in addition to user base. Huh?
I think it's same around the same.
Okay.
Assessment, yeah.
That's the same thing. Okay. And then here, in future, maybe a concept of key store broker, which the user authenticates to, and the broker lists the key stores the user can select from that they have access to. True, but a key store acting on behalf of other key stores through, a pop-up level, it's still a key store. So I do not know if we need this here.
I think the point is, there could be a central, more an implementation detail, right? Where the workload owner doesn't necessarily have to know which endpoint to talk to. There could be a concept of broker where they could select which particular key store they want.
Yeah. So what do you want to do about this? Keep it somehow added to the text somewhere, or?
No, it's more an implementation consideration when we have to deal with multiple key stores.
Yeah. Okay. What does anybody else think here? I don't feel it belongs.
Yeah,
like a CA could be a broker of CAs. Like anything can be broker or anything.
Right. Which again, it's, if we talk about recursive patterns at some point, we can include that in that same thing. But the issue, of course, is you have multiple key stores and multiple CAs, then now you have to have all this, times the number of, whatever stuff. So I think it's captured by just saying all of this ends up being recursive and needs to be, if there's more actors in the implementation, then every single relationship between the actors needs itself to be secure.
Okay. So what do I do with the comment?
I think we can remove it.
Okay. Sounds good. Let's keep going. We added the row. All right. So now we're at the acquisition phase, threats and mitigations. Did we finish it last time? I just want. I don't remember.
I do not remember either.
I think we ended let's just redo it just in case. So again, in your own screen, you can open up this flow chart right here, so you can follow. This is the acquisition phase, and following the acquisition phase, there is a step-by-step description of everything in the acquisition phase. Okay, so I'm gonna have on the screen the threat model. So step one, we have the same as step 13 under provisioning, right? So this is where the encrypted signing key, the wrapped signing key, and the plain text workload credential are delivered to the workload. So there is nothing else to say here. Number 2 and 3, those steps have no threats, so they don't require any mitigations. Again, please verify to see if there is anything that you think might be in play. Let me duplicate the step so I can do it myself too. Yeah, this is where we generate the CDK pair and generate the evidence. So yeah, there is nothing there. Let's say basically 2 or 3. These cells can be merged. And this row can be deleted. Okay. Okay. So that's fine. Number 4, authentication request might be prevented from being delivered or tempered within transit. So that's another service tampering. This is where we're basically saying that attestation flows, this is a conversation with the verifier. We're assuming that the conversation flows are designed to be temper resistant. Is this a good assumption? Any dissenters? Okay. Moving on to 5 and 6, this is where we appraise the evidence and compute attestation results. Now, notice the verifier here is not authenticating the workload. It simply receives attestation evidence from the workload. So we're basically saying rats already got that licked. Now, you could be submitting it. There is information disclosure if we go to the wrong verifier, because you'll be giving attestation results. You may accidentally disclose your composition, your reference values, right? So we should say something about that.
That's a very good catch. That's a very good catch, because indeed the more sophisticated and the more optionality you have in those flows, the more risk you have of
Yep.
exposing or leaking
Okay, we're
information.
going to have information disclosure. Attestation request sent to the wrong verifier or over an unencrypted channel. Discloses information about workloads composition to an unauthorized party. All right, so we got that. Utilize TLS, transport level security. We can say workload should authenticate the verifier.
Yes, so
and
it needs the public key of the identifier. It needs to know who it's talking to.
Yeah, authenticate the verifier and should establish a secure transport channel with the verifier prior to sharing the attestation results. Great. Speaking
You
of
say
which,
authenticate, do you just mean the some whitelisted endpoints, right?
well, I mean, how we don't say the mechanism, but it could be any mechanism. It could be that you just have a closed network and some firewall rules. Could be that you have IPsec. Could be, but know who you talk to, know who you share information with. Encrypt the traffic in transit if you think there may be unauthorized parties. This is not a must, because you may be okay with this information disclosure. This is the way, like in other cases, a must is a must. Like you really, But this I think is a should. Again, feel free to challenge me on anything. Like this is, maybe it's a must. All right, going to 5 and 6. We'll praise the
I think it's
evidence.
ID, right? Information disclosure is ID. I think you just kind of like
yeah. How do I? Yeah,
the
I use ID elsewhere.
oh.
All right. So on 5 or 6, if the wrong appraisal policy for evidence verifier leads to incorrect appraisal decision, so you need to secure the appraisal policy, log and audit all requests and responses. So I think we got that handled. And then you return the attestation results, including a public CDK.
Do you have a similar thing for the reference value somewhere? Or is that
For which step?
the appraisal is you appraise the evidence
And
against reference values, right? Yeah, you need, because again, if you want to verify that something matches something else, you need to secure both.
Good. Okay. All
And a lot of the
right.
times we don't have control, right? Like for Azure, they have their own verifier endpoint, right? we don't control those policies. Those are all out of the box from Azure, right?
Yeah. Well, I mean, again, we can, we make recommendations here, but it's really, we can have an addendum basically saying this is what you're looking at in Azure. This is what you're looking on GCP. Like if we really wanted to, or an organization can come up with its own. We can contact Microsoft and say, hey, we found a bug, you're not doing this or that, and this is the problem we're facing, and see what they say. Okay. 7.8, we got denial of service and tampering. This is where we returned attestation results to the workload. Now, presumably over the same secure channel established in 4. So I don't know, information disclosure is still applies. Should we say something there?
Yeah, it's digitally signed, so
Yeah, but I mean, is there information disclosure about attestation results? It's like, I mean, there is still an information disclosure threat
Yeah,
that we might as well mention.
there's in fact more, because now you've not only said, this is the composition and all that good stuff, you also said, oh, and this matches the reference value. So it's actually a good composition and all that good stuff. So it is even more information disclosure.
And while you're typing that, first off, hi guys. I mean, it's been a while, and I apologize for it.
How are you doing?
And I'm not sure how frequent of an attendee I might be. I'm pretty swamped with my other priorities. However, I first coming clean. I haven't looked at the doc. I'm kind of learning as we go. What I have, like a perspective of just looking at the diagram, I think maybe you guys already have considered it, but there is a risk with the say liveness of a challenge when the key store is getting the attestation result. I think in a typical scenario, I mean, the threat would be if the appraisal result is stale, then of course you would be, kind of fooling the key store to give you the key, still thinking that it's, using the latest and greatest, say, TCB patches. However, that might be replayed from the very old state where you were up to date and now you might be out. And of course, some appraisal policies are going to make sure this never happens, because you would never be able to cheat as to your TCB state. But still, I think it would be prudent for the key store to first challenge this whole or kind of non-seed this whole exchange, so that when it's receiving the attestation results, it knows it's getting them in response to this particular session it's operating in, rather than relying on, say, wall clock to synchronize that them being, up to date.
I think it's correct. Yeah.
Well, I forget which document it was in, but freshness is kind of assumed in the attestation flows here. Like, so for instance, when you go to the verifier, when you say request attestation evidence, it is, it may be that in step 4 here, you are actually first getting some freshness. We're basically saying we're piggybacking on top of the rats flows. Though it doesn't hurt to add
But that's
something
your
here.
workload to verifier freshness, which I agree. You can just say it's baked into the protocol between those two parties.
Right.
But then you have a third party, the key store, which either has to derive the freshness claims of the verifier to become its own, or it has to have a separate mechanism to trust in those freshness. I mean, we should at least call them out. Ideally,
I
for a
don't quite get it. So look, hold on a sec.
Sure.
Let's go back to the provisioning phase. In the provisioning phase, it's the workload owner that decides on the workload identity and precomputes the anticipated attestation results. Right? Now, the attestation results it precomputes obviously doesn't include everything. It does not include the CTK that each workload is going to generate for itself. That's the decryption key that it would be using to receive the the key material necessary to unwrap the signing key. But the rest, this is not a freshness thing. Like if your workload measurements change, then the provisioning needs to be redone, right?
Could you please scroll up maybe to because I'm not talking provisioning phase, I'm talking acquisition phase. I'm specifically saying the time gap between steps 7 and 8 being pretty big.
Oh, I see what you're saying. Okay, hold on. Let's think about that. So you return your attestation results, and then you go to the key store and you say, I would like to get the unwrapped CSK based on these attestation results. So you're saying, well, but here's the thing. If the attestation results say a certain thing, right? And the key store has a policy that's called the CWK access policy that matches those attestation results. What does it matter how long it's been?
Because the appraisal tends to be fixed in time. I mean, my policy of today might be trusting the latest and greatest CVE patches that have been published as of today. A year from now, you would be, way degraded because attacks exists.
Oh yeah, well then you go change your access policy. You go, that's what I'm saying. You repeat your provisioning.
But if and again, maybe it's in the doc, but depending on the level of fidelity of the attestation results, if they are kind of pre-appraised for me, at least somewhat, then I'm trusting that the verifier did its job already. And the verifier policy has mutated over those. I mean, if it's a dumb policy, just replaying the claims, not appraising anything, then yes, you are appraising at the step number, I think it's 9, and then nothing has moved. However, if there is anything the verifier has done with the actual reference values, which I think you are saying, those could have moved.
Okay, so I believe this is covered. It should have an explanation in the document of why it's covered. I actually think one exists. I need to look. It's a big doc now. I don't have it all in my head, but let me walk you through what I think. So somewhere in the security considerations down below, credential rotation, right? So there is a section that still has a to-do on it. So talk about reusing the same credential signing key while periodically extending the expiration time of the corresponding credential. And talk about the need to periodically rotate the credential signing key and the corresponding change to the credential itself. So why is there that credential rotation? This is on the CWK access policy. What it should say at some point in this document, and if it doesn't, it needs to say that. So let's go back to the provisioning phase. We'll go to the provisioning phase and we say, we expect the following and attestation results to come. This is before evidence. This is nothing about evidence, right? In this stage, we're basically saying, these are the attestation results we expect the workload to generate if the evidence submitted by the workload is good, right? So this is between the workload and the key store. And then the idea is that so now say there is a vulnerability in the workload, and the vulnerability in the workload will basically say the attestation results may in fact have something new in them, right? So the idea is if there is a significant vulnerability in the workload. By the way, there are two branches here. This is under deployment considerations. We're going to cover that. One is I introduced a minor feature or something into the workload, and I don't want to rotate all the credentials over it. And there is another one saying there is now a major version change or a major vulnerability that was discovered. And now we need to make sure that old credentials that have that vulnerability can no longer reuse the old credential. And the way you would do that under this scheme is you would go and rev the anticipated attestation results. As in, you will say, attestation results should have, for instance, in the return, maybe the SV, the latest SVN, right?
Okay, Mark,
and again,
then...
this all needs to be written up. But then, if that happens, if a workload authenticated a long time ago and it has the attestation results with an older SVN, well, eventually it'll stop working.
But then when are we providing, because there's two things. You covered one of them. You covered the claims of the workload itself. But the real threat I see, like looking at the diagram, is really at step 8, I can get a stale result of step number 7, which is the verifier's doing. So then you covered the part about what the verifier is appraising, which is the workload. What about the verifier itself? Like, is the verifier, are the verifier measurements also changing the anticipated verifier measurements? Are we even covering those at the key store site?
What do you mean the verifier measurements? I'm
I
not
mean, the
exactly sure
verifier of today might have been hacked. Again, assuming it's, either it could be inherited trusted, but let's assume a bit more real world scenario. The verifier is in some of a kind of a TE. Today it's, verifying something matches. Tomorrow it might verify something else. So
Okay.
freshness of that verifier's TCB is also of interest to me. So I would at minimum want to know when I'm getting the claim signed by the verifier, when they have originated, at which posture of security posture the verifier was presenting at the time.
Okay. So, okay, I hear you. So there's a couple of ways to address that. One is, I think it's more of a crude method, but you timestamp and you're basically saying, if you give me attestation results, I want you to timestamp them, and I'm going to be enforcing a delta, for the turnaround between step 7 and step 8.
Some TEs don't have time in them,
Yeah.
right? So they have to rely on external time that's not part of the TCB.
Right.
SGX doesn't give you access to
Yeah,
time.
I don't know how TEs get current time. It's an ages-old problem. The second one could be that if I revved my verifier because the old verifier was buggy, right? I could sign the attestation results from step 7 with something from the verifier, and then have the key store verify that signature. And if the verifier signing key has changed, then that would invalidate all the old attestation results. So again, this is great for the threat model. So Matesh, thanks for bringing that up. We can definitely reflect that. But
to be fair, I mean, before going to the solution, I think the threat really is stale evidence being generated at by the verifier presented to the key store. So I think the threat materializes at step 8 because you don't control the time passage between 7 and 8. And then mitigation-wise, I mean, yes, you mentioned timestamping. You can have some coincidental markers, but also if you want to have it as written in a single flow, when there is not like, separate entry where you first do the appraisal and then do like a passport model and somebody else maybe is presenting the evidence, the simplest mitigation out there is just interact with the key store first, initiate a session, and then say, hey, within the session, I'm going to give you this result. And then, have the verifier include this nonce or whatever challenge that key store starts at the, session initialization. Let's bake it into the verifier output. Then you have, 100% guarantee they are talking to each other within whatever session lifespan that the key store controls. But these are solutions. I mean, what I wanted is really to make sure we have the threat captured, and solution-wise, we can do whatever.
Okay, so the mitigation might be, again, help me write this up. So I'm basically saying there's a vulnerability in the verifier that causes it to produce wrong attestation results, or something like that. The workload caches these attestation results and triggers accidentally or deliberately causes the key store into releasing the CSK or incorrectly. Verifier signs the attestation results, signs or timestamps
Yeah, I mean, if trusted time is available, then timestamping of attestation results is enough.
Well, you also need to securely bind them to attestation results, right?
Yes.
Well, of course, I mean, I'm assuming whatever is the output of the verifier is signed, but you're right, it should be called out.
Okay. I don't know. Like, help me phrase this. Fairness, attestation result in the key store validates this before anything. CW,
So that's what I would call mitigation number one for the verifiers who have trusted time source, however you define trusted. And then mitigation number two, an alternative to number one, is the key store initiates or issues a proof of liveness challenge that the verifier has to respond to, and the response is embedded into this verification claim. But unlike there is a pre-step then on our diagram, there would be like step before number four.
And this kind of assumes that there is a line of sight between the key store and the verifier, or the workload needs to engage in
the workload likely would
more
need to broker
steps.
that communication.
I'm very loath to introduce legs into protocols, right? They add latency and they add fragility. So, there are many ways of skinning this cat. I don't know if we should be documenting every single one, but we can have alternatively.
Yeah, though I have to point out, I mean, the trusted time is a very complex problem, as Manu said. I mean, yeah, I guess I'm in the camp of those guys who cannot produce the worthy enough TE that is just having the capability. But that's, an actual limitation of the hardware. Trusted clocks are really difficult. They are, not so available.
Yeah.
Which is why typically in the, your typical crypto protocols, you just do a nonce-based exchange and kind of move past it.
Yeah, I kind of back that too. I think it's important that we have this. And again, this additional complexity here comes from the fact that we separate all these different actors, and now we need to just stitch together. We need to bind together all these conversations to make sure that everything is part of the same session. So, not to just hammer the point again, but if you collapse those things together, you have the verifier and the key store, in one thing. You just don't have that problem. So it really is because we're trying to separate all these actors that we basically saying every interaction between any two actors needs to be authenticated, protected, and then verified to be within the same session.
Yeah, put differently, replay protection threat is material when those actors separate.
That's even more elegantly said. Yep.
All right. I trust you guys to go and edit the text because I don't know what to say, but you have the document.
I think that the way you phrase it is good. I mean,
All right.
It's giving us enough kind of a hook to say it needs to be there, it has to be considered. I wouldn't change the diagram, by the way, because depending on how you deploy it, it might be a material threat or not. It's just, I think, enough for somebody analyzing it to realize, yeah, if I'm separating those two, I have to consider it.
Right. Okay. So there was nothing on 10. 10 is just when you encrypt the CWK with the public CDK from the attestation results, and then 12, 13, again, the CWK is decrypted inside the workload, and the CSK is decrypted with CWK. So all of this can be merged. There's nothing there. But please let's take a look, finally at step 11, if there's anything else.
Is there a, I guess, expiration date that the key store would communicate to the workload, by which, of course, a well-behaved workload would need to either re-request the key because the key is going to become invalid for its usages, or maybe the workload should be a good citizen and sanitize its copy as long as it's running. I mean, it's kind of embedded in the credential, maybe credential expiration dates.
Yeah, the credential expiration handles that.
Okay, fair enough.
Okay. All right, I think that's it. I will go through and I will clean up a little bit. Add the additional steps as we agreed upon. Then you can do an offline review. Before we wrap up. So remaining steps would be to go after the Fed model is done. Let's see. It would be to go look at credential rotation, performance optimization, Cephania, some deployment considerations, and then we'll be wrapping up this document. Separately, what I want to, we're not going to have time in the next 10 minutes to do this, but please do this offline if you can. So over here, there is a pull request. This is from, so I met with Joe Salloway. He's a principal in Whimsy, and I basically said, we need to separate credential usage from credential acquisition in Whimsy reference architecture. And there is a pull request where he attempted to do it. Now, Whimsy is not just about confidential workloads. My conversation with him basically saying, make it possible for workloads that are confidential alongside every other workload that you have to go and engage in credential provisioning before the credentials are used. And then most of Whimsy, the service-to-service protocol, how you go to reverse proxies and all this other stuff is on the credential usage side, which for us is not interesting. But this pull request is right here. I provided the URL in the doc. Please take a look, comment, see if it's well written, because this is the time to properly engage with them on this. This is a big win for us that they're even considering it. So, because again, we're not presenting at the Shenzhen ATF, but they basically said they also said as soon as you have your document, you can bring it to the Whimsy interim meeting, so which is the other document. But this is our contribution directly to the Whimsy working group to help them, document how provisioning might happen. All right, with that, we're probably going to wrap up. I'll see you guys again in a week. Thank you so much for all your inputs today.
Thank you, Mark.
All right,
Thank
it's
you,
always
everyone.
good to see you.
Thank you,
Take
guys.
care.
Good
Take
to
care,
see you
guys.
after a while.
All right.